Welcome to Unacademy. This is your Sathyamoorthy sir. Let's crack it. So welcome to the second session on limits part 2. And today it's continuation of the previous video, right? In the previous video we have discussed about the limits, concepts and types. Today we are going to solve few previous questions on the limits category. Before moving to the question, here coming to the Unacademy Compact. So Unacademy, they are conducting the India's largest weekly competition for GATE. Access your GATE preparation in 60 minutes. Challenging and original GATE questions curated by the best educators in the platform, and take it live to compete with the best. Super fast and fun with the All India Live Leaderboard. Then after completing the test, you can get the detailed video solution for all the questions for the respective streams. And already June 6th and 13th over, and next to compact in this month, 20th and 27th Sundays, next 2 Sundays, 11 a.m. the session starts, the quiz starts at 11 a.m. So try to enroll using the code Moorthy536 to crack the compact. And price hike is coming soon, right? The price very soon the prices for the GATE and ESE subscription will be increased. To avoid the price hike, so try to subscribe now itself so you can get the benefit. And Spark and Web, there are 2 batches for the GATE 2022 and 2023 completely in English for the mechanical engineering. Praveen Kulkarni sir, Devendra Singh Negi, Vivekanandan and myself, we 4 together handling the complete course for the mechanical engineering completely in English, right? Already the engineering mathematics going on, as well as general aptitude going on, and I'm going to start the theory of machines July 20. Now the new course, we start with the August Tyagi sir, theory of machines, 23rd June. So I think it's hiding. It's 23rd June and it's 10:45 a.m. we are starting the new batch for the mechanical engineering. So try to subscribe now itself to avoid the price hike. Now we are moving to the calculus, limits part 2. Quick revision for the types, then we are moving to the previous questions. Today we are going to discuss one of the new method in the limits. It's a logarithmic format. So how we are going to solve the logarithmic format? So this is what today we are going to discuss. Limit of a function and type 1. Type 1, it's direct substitution. When we are getting the finite value, it belongs to the type 1. Type 2, if you want to find the limit of f of x when x tends to infinity, whenever the limit tends to infinity. Whenever the limit tends to infinity, then we need to substitute x is equal to 1 divided by y. The another variable in terms of 1 divided by y we are substituting. After simplifying the condition, we are applying the limits y tends to 0. After substituting x is equal to 1 divided by y, the given function is simplified. Then we are applying the limit as y tends to 0. Is it clear? Again we are applying the limit as y tends to 0, then we are getting, and in this part itself, the one more thing, type 3 also included with the type 2. I will give you some previous questions in the forthcoming slides. There are 2 important limits. Limit here x tends to a, x power n minus a power n divided by x minus a is equal to n into a power n minus 1. Limit theta tends to 0, sin theta divided by theta, it's equal to 1. Indeterminate form, it's a type 3, it's indeterminate form. So what is meant by indeterminate form? While evaluation of some limits, we are ending with the form, it's indeterminate form, 0 divided by 0, infinity divided by infinity, or 0 into infinity, which do not represent any value. Such expressions are called the indeterminate forms. Here the L'Hopital rule is used to get a finite value whenever we are ending with the indeterminate forms. The L'Hopital rules states that when we are ending with 0 divided by 0, infinity divided by infinity, or 0 into infinity, any one of these indeterminate form, then we need to differentiate the given function numerator separately, denominator separately. We are differentiating the numerator and denominator separately. Then again we are applying the limits until to get the finite value, and repeatedly the indeterminate form formula it will be applied, right? Now we are going to discuss few previous year questions. Here it's a computer science engineering 2016 set 1 mark question. Set 1 mark question. While applying the limit, now apply the limit x is equal to 4. If you substitute x is equal to 4, we are getting sine 4 minus 4 divided by 4 minus 4. What will be the value? It's 0. If it is 0 means apply L'Hopital rule. Apply L'Hopital. It's a 0 divided by 0, it indeterminate form, L'Hopital rule. So what it states, L'Hopital rule. So coming to the L'Hopital rule, so we need to differentiate the numerator separately, denominator separately. Sine 4 minus x differentiation equal to, it's a x minus 4, cos x minus 4, and denominator x differentiation 1, 4 differentiation 0. Now substitute the limit again, x is equal to 4. If you substitute x is equal to 4, it's a 4 minus 4 divided by 1. It's equal to cos 0 divided by 1. Cos 0 is equal to, what will be the value for the cos? Cos 0 is equal to 1. Now the solution, it's numerical answer type, that means it's a fill in the blanks. The value for the question is, it's 1, right? Solution. The one more question. Now it's a very important, directly we can get the solution for this kind of question. It's a civil 2010 1 mark question. Here limit sine of 2 divided by the formula is that what formula? Whenever the limit extends to 0, sine nx divided by x is equal to n. Nx divided by x is equal to 1. Here n is equal to 2 divided by 3. So the solution must be 2 divided by 3. Otherwise we can do the L'Hopital rule. As per the L'Hopital rule, if you substitute x is equal to 0, we are ending with 0 divided by 0. Now apply the L'Hopital rule. Apply L'Hopital rule. While applying the L'Hopital rule, what we are getting here? Yes, here it's equal to sine differentiation equal to limit extends to 0, sine differentiation equal to, it's 2 divided by 3 into cos 2 divided by 3 into x. The denominator differentiation is equal to x differentiation 1. If you substitute the value, what we are getting? It's 2 divided by 3 cos 0. It's equal to, solution is equal to, it's 2 divided by 3. It's a one more direct method, right? One more direct method. Next question. Here the same formula. So what we have discussed in the previous one, it's a civil 1997 1 mark question. It's 28 facts. Questions are very easy, but nowadays you need to know the basics. Then by applying the basics, you can crack the remaining things very easily, right? Okay, fine. Next one. Here it's a new method, limit method, type 2 problem. Here it's type 2. So how it is type 2, I will show you. Listen. It's a type 2. So this is a type 2. If you want to find whenever the limit extends to infinity, good evening, Harish. Fine, extends to infinity, it's type 2. So what we need to do, whenever the limit is infinity, so we need to assume it's 1 divided by another variable. After simplifying it, we are setting the y tends to 0. I will show you, so you can get it very easily. In this question, here the limit of the function n tends to infinity. Let limit So limit n tends to infinity. Therefore, what we are going to take, it's n is equal to let n is equal to 1 divided by y and y tends to 0. First we need to substitute n is equal to 1 divided by y. After that we are simplifying the equation. Then y value it's equal to 0. Now substitute limit y tends to 0 instead of, if you substitute the value y is equal to 0 in this equation, what we will get? It's equal to y is equal to 0. Therefore 1 divided by 0 is equal to 0. Now the limit n is equal to n is equal to n is equal to 1 divided by y. So it's 1 divided by y, it's a whole divided by root of 1 divided by y the whole square plus 1 divided by y. Now do the simplification here. Now it's a limit y tends to 0. Now take the y commonly outside. It's 1 divided by y the whole divided by 1 divided by y. It's equal to, so into 1 divided by, if you take the 1 divided by y outside, then what we will get? Okay, nice. It's equal to 1 divided by y plus 1. 1 divided by y plus 1. Is it clear now? From the square we are taking outside, right? Listen. Okay, it's 1 divided by y as plus 1 divided by y, it's cancelled. The values cancel. Now the limit y tends to 0. It's 1 divided by root of. So we need to substitute the value. Now if you substitute value is equal to 0, then what we will get? It's 1 divided by 1, right? The value of y is equal to 0. Here n is equal to 1 divided by y. So the 1 divided by y we are taking commonly outside. It's commonly outside. So from here we need to take from the root, right? While taking this value from the root, so here it's y square. Excuse me. Yes. Here 1 divided by y is taken outside, right? While taking the value 1 divided by y, then what we will get? It's root of 1 plus y we will get. Yes. So how we are simplifying this equation? It's equal to this value 1 divided by y square plus 1 divided by y. So we need to take the LCM here. If you take the LCM, what we will get? 1 plus y divided by y square. In that 1 divided by y square, while taking the 1 divided by y square, it's equal to 1 divided by y, right? Now it's 1 plus y. Now substitute y is equal to 0. If you substitute y is equal to 0, 1 divided by root of 1 plus 0, value is equal to 1. The solution for this question is equal to D. It's a type 2. Is it clear now? Type 2 problem. Next one. Now it's very important part. Functional power function. Whenever they are giving functional power function, so we need to use the logarithmic function. It's a computer science engineering 2015 set 1 mark question. Here x also variable, 1 divided by x also variable. So it's variable power variable. Whenever we are getting the function as variable power variable, so we can't apply, right? So what we are going to do? Let us assume capital X is equal to limit x tends to infinity x power 1 divided by x. Now it's an infinity case, right? Whenever it's infinity, then one more thing, small x is equal to 1 divided by y and the limit is y tends to 0. So this is what we need to apply here. This is what we need to apply here. Now the value I am giving you, the value I am going to give you. Good evening, Evangeline. Students, in case you are having any doubt while I am explaining the concept, so kindly ping your doubt immediately so I can give you the reply, right? Now capital X is equal to limit y tends to 0. So what we are doing, the x is replaced by 1 divided by y. Therefore y tends to 0, here 1 divided by y power 1 divided by, it's 1 divided by y, it's equal to capital X is equal to limit y tends to 0, 1 divided by y power y, right? Here also it's a power. Now take log on both sides. Now we are going to take the log on both sides. Take log on both sides. So while taking the log on both sides, logarithmic of capital X is equal to limit y tends to 0, logarithmic of 1 divided by y, 1 divided by y power y. Now we are going to apply one method. So what method we are going to apply? Listen, from this step, logarithmic of capital X is equal to limit y tends to 0. Now it's y into logarithmic of 1 divided by y, logarithmic of 1 divided by y. We are substituting the value here. While substituting the value, what we will get here? We are taking this y front side. So how we are taking this value front side? We know the one more logarithmic formula. Yes, what logarithmic formula? Logarithmic of m power n is equal to n into logarithmic of m. So as per this logarithmic formula, we are taking this value y front side. Therefore it's equal to, now substitute y is equal to 0. Logarithmic of infinity is equal to not defined, it's equal to 0. If you substitute y is equal to 0, 0, and logarithmic of capital X is equal to 0. But what value we required here? It's capital X is equal to, we require the value here, capital X is equal to limit x tends to infinity. So this function value only we require, x value, capital X value. But what we are getting here, it's a logarithmic of capital X. Now again take antilog on both sides. Antilog on both sides. Take antilog on both sides. So while taking the antilog, antilog means exponential function. Exponential of logarithmic of capital X is equal to its e power 0. Now the exponential logarithmic cancel, capital X is equal to e power 0, it's equal to 1. Therefore solution for this question is equal to 1. It's C. It's option C, right? So it's a variable power variable. So one more example I am going to give you for the variable power variable, so you can get the clarification on the variable power variable. Now again here 1 plus x square is variable. X is variable. Here e power minus x also variable. Whenever variable power variable, so we need to assume this total function as x. It's a logarithmic function. Now it's infinity, right? Instead of the infinity, we are going to substitute x is equal to 1 divided by y and y tends to 0. So this is the limit we are substituting. Here. Now substitute these limits here. Now the limit y tends to 0, x is equal to 1 divided by y. Therefore 1 plus 1 divided by y square power e power minus 1 divided by y. Now let us assume capital X is equal to this function. It's a functional power function. Limit y tends to 0, 1 plus 1 divided by y square power exponential power minus 1 divided by y. Now take log on both sides. In order to eliminate the functional power function. Now take log on both sides. If you take the log on both sides, logarithmic of capital X is equal to limit y tends to 0. It's logarithmic of 1 plus 1 divided by y square power exponential power minus 1 divided by y. Minus 1 divided by y. Now, as per the formula, logarithmic formula, logarithmic of capital X is equal to limit y tends to 0. Now the exponential function is taken front side, e power minus 1 divided by y into logarithmic of 1 plus 1 divided by y square. Now substitute y is equal to 0. If you substitute y is equal to 0, then what we will get? E power minus infinity. E power minus infinity into logarithmic of 1 plus 1 divided by 0. So it's not defined. E power minus infinity is equal to 0. E power minus infinity is equal to 0. So it's a logarithmic of capital X is equal to 0. Again, take antilog on both sides. Again, we are going to take the antilog. Take antilog on both sides. So if you take the antilog, then what we are getting? Exponential power logarithmic of capital X is equal to exponential power 0. Exponential power 0. Therefore, capital X is equal to e power 0. It's equal to 1. So this is the final solution. So we have assumed the total function as x initially, right? So the solution for this question is equal to 1. It's C. Is it okay now? Yes or no? Students, in case you are having any doubt, immediately ping your doubts here, so I can give you the immediate reply to you, right? So kindly ping your doubt in the chat box, YouTube. And the complete engineering mathematics I am handling in the Plus platform, Unacademy Plus. And if you want to crack all the engineering mathematics questions, so subscribe into the platform, Plus platform. Kindly follow my profile so you can get the engineering mathematics complete course in the Plus platform. Okay, one more example I'm going to give you. It's a civil engineering 2015 set 2 2 mark question. The same kind of question here, 1 divided by x, and power also it's x. It's a variable power variable, right? So coming to the variable power variable, let us assume the same thing. Limit now x tends to infinity, therefore x is equal to 1 divided by y. Arman, it's option D you are giving. Okay, we will check it. It's y tends to 0. Is it clear, Arman? Arman Nabao. It's y tends to 0. So what we need to do here? Now, the limit, instead of limit y x tends to infinity, it's y tends to 0. It's 1 plus 1 divided by y is equal to it's y, and 2 divided by y. It's a function. Let capital X is equal to limit y tends to 0, 1 plus y power 2 divided by y, power 2 divided by y. It's another example I am giving you. Now take logarithmic on both sides. Take log on both sides, and if you take the log on both sides, it's logarithmic of capital X. Logarithmic of capital X is equal to limit y tends to 0. It's logarithmic of 1 plus y power 2 divided by y. 2 divided by y. Is it okay now? Okay, I'm giving it. Now, as per the limit formula, we are taking this value from say logarithmic of capital X is equal to limit y tends to 0. It's 2 divided by y. 2 divided by y, and logarithmic of it's 1 plus y. And if you substitute y is equal to 0, then what we will get? And it's equal to 0 divided by 0 log. Okay, logarithmic of 1 is equal to, if you substitute 2 into logarithmic of 1 plus 0 divided by 0, we are ending with 0 divided by 0. Now apply the L'Hopital. Apply L'Hopital rule. Apply the L'Hopital rule. So while applying the L'Hopital rule, the limit logarithmic of capital X is equal to limit y tends to 0. Now 2 into numerator differentiation. So we can keep this y 2 into logarithmic of y in the numerator. Now it's differentiation equal to 2 into 1 divided by 1 plus y differentiation equal to 1, it's a whole divided by y differentiation equal to 1. Now substitute y is equal to 0, 2 divided by 1 plus 0, it's equal to 2. Now logarithmic of capital X is equal to 2. Take antilog on both sides. Take antilog on both sides. While taking the antilog, then what we are getting here, listen, it's equal to exponential power logarithmic of capital X, it's equal to exponential power 2. Now capital X is equal to e power 2. Yes, no, it's D. Here option D is the right answer. It's e power 2. E power 2 is the right answer. Is it okay? It's a type 2. In the previous video, in the previous class, we have discussed about the type 1, type 2, type 3 difference and everything. Now it's the one more time the combination of type 2 and type 3. That means infinity. The limit tends to infinity as plus L'Hopital rule combined problem. It's very important. It's a repeatedly coming method in the limits. Is it okay? Is it clear now? I hope it's clear for all the students, right? One more time I will tell you the price hike details in the platform. Yes, students, the price hike will be there in the forthcoming months for the GATE and ESE category. And try to subscribe now itself by using the referral code Moorthy536. It's a code Moorthy536 to avail the 10% offer. So you can avail the 10% offer through this code in the Unacademy platform for any goal, not only in the GATE and ESE. You can get the 10% discount in all the goals, right? The price rate will be there. Then batches are the completely mechanical engineering course, and now the complete engineering mathematics course I am handling is common for all the departments. In forthcoming months, we are going to start the mechanical engineering core subjects. Okay. So try to subscribe using the code Moorthy536. This batch already started 16th June. Okay, 2 days day before yesterday. So if you start the preparation now, this is the right time to prepare the complete engineering, mechanical engineering syllabus for the GATE from your home itself. Unacademy provides you the complete comfortable zone, so you can learn completely from your home itself. So you can learn among all the top educators in India through the Unacademy platform, right? Okay, thank you, students. Tomorrow we are going to start the new topic in the engineering mathematics in the next session.